For this question, this function, for the first part, we are going to find out its critical value. So for question C, we're going to find out the critical value by finding its first derivative. So power move to the front, power minus 1 will give us x cubed. And then power move to the front will give us negative 6, power minus 1 becomes square. Then power move to the front is 11, power minus 1 becomes x. Differentiate negative 6x, we get negative 6. We differentiate constant 3, we get 0. So in order to get critical value, we have to let our first derivative function equals to 0. So let this cubic function equals to 0. So you can use your calculator to find out to solve this critical value. So from your calculator, you can obtain our x here. Solution is 1, 2, 3. So that will be our coordinate. So for x equals to 1, we're going to find out its coordinate y. Substitute 1 into the function. So when we substitute 1 into the function, we get 3 over 4. And then continue. When x equals to 2, so we get coordinate 1. So same go to when x equals to 3. So from here, we can conclude out 1, 3 over 4. Another point is 2, 1. Another point is 3, 3 over 4. They all are critical points. So after we getting our critical point, for our part 2, we are going to use our first derivative test to determine this relative extremum point. So in order to use our first derivative test, we are going to use our table. So since we have 3 critical points, so we will have 4 intervals. Where the first part is define our interval. When we have x equals to 1, x equals to 2, and x equals to 3, we want to see our interval will be x less than 1, and then x is between 1 and 2, x is between 2 and 3, and x will be more than 3. So we want to see our gradient of the tangent in this interval. So our test value here will be randomly selected. So as x equals to 1, we can select 0. Here we can select 1.5. Here we can select 2.5. More than 3, we can select 4. We are going to test this value by substitute it into our first derivative test to see the result of the gradient of the tangent. So the gradient of the tangent, the result here will give us negative, positive, negative, and positive, which means that our gradient of the tangent for this interval is decreasing, from then increasing, then decreasing, then increasing. So the critical point at here will obviously is a minimum point, because the gradient before it will decrease first, then afterward increase. So the critical point for 2 here, so it is a maximum point, because the gradient of the tangent before it is increasing, then they're going down. Then the critical point for this, it will be decreasing. So from here we can verify their extremum, relative extremum, where we come up a conclusion 1, 3, 4, and 3, 3, 4. There are minimum points. So meanwhile, another point 2, 1 is maximum point. So when we talking about first derivative test, we are going to see the gradient of the tangent of the curve. So we move to the next part. For the part 3, they say use second derivative test. So we are going to differentiate our function again. So from the first derivative test that we get here, just now we substitute our value to see the gradient of the tangent, whether it's increasing to or decreasing, in order to verify it is maximum point or minimum point. So from this first derivative test here, we're going to differentiate again to obtain second derivative, so that we can undergo second derivative test. So when we differentiate it again, power move to the front, become 3x squared, then continue minus 12x, then differentiate 11x become 11. So that will be our second derivative test. Second derivative test is talking about concavity. So we are going to test every point of it. When x equals to 1, we substitute it into our second derivative function here. So it is positive. Positive will be concavity upward. So this is a minimum case. Then we proceed for the second point. We get negative. So negative will be concavity downwards. So this is our maximum case. And our critical value number 3. So it is positive result. So positive result, concave upward, minimum point. So from here we also can obtain the same result, where 1, 3, 4, and then another coordinate 2, 1 will be a maximum point. So as you can see here, the result will be same, but the test and the presentation of the test is different. So second derivative test involving our calculation to see concave upward or downward. Meanwhile, first derivative test is talking about the gradient of the tangent, so it is the It needs the interval before the point and after the point. So to see the tangent changing. So then from here verify, then identify our critical point whether it's maximum or minimum.